Hello, good morning. Welcome to PHY309 Quantum Mechanics I. I am Dr. Agbaoye Ridwan Olamide, the facilitator for this course. I'll be taking you through this course using the course material as a guideline and explaining concepts, solving problems, and answering questions based on our interactions. So join me as we take PHY309 Quantum Mechanics for the rest of the next 8 weeks. PHY309 is a 3-unit course, and the title of the course is Quantum Mechanics I. This course is divided into 4 modules, and each module is subdivided into units. In the first module, we'll be interested in vector spaces and operators. In unit 1 of the first module, we'll look at vector spaces, linear independence, basis vector, scalar products, inner product, and norm of the vector. Then we would have unit 2, orthogonality and autonomality, and in our unit 3 we would have operators. In unit 2 we'll be looking at orthogonality and autonomality before we proceed to module 2, and in module 2 we'll be interested in the inadequacies of classical mechanics and the Schrödinger equation. The units that are inclusive consist of the inadequacies of classical mechanics as a unit, the Schrödinger equation, and the postulates of quantum mechanics. Within this module, we'll be looking at black body radiation, we'll be looking at photoelectric effects, we'll be looking at Compton's effects, we'll be looking at Bohr theory of hydrogen atom, we'll look at the Heisenberg uncertainty principle, and the wave-particle duality. Then we'll have a tutor-marked assignment before we conclude our module 2. And that takes us to module 3. In module 3, we will be interested in the time-independent Schrödinger equation in 1 dimension. Then it is subdivided into 2 units, which includes the bound states and the scattering states. We will look at the particles in an infinite potential well, and also we would also be interested in particles in a finite potential well. Of course, we'll take our total marked assignment. In this case, we'll look at concepts, solve problems, then we'll discuss the nature of the problems before we proceed to module 4. In module 4, we will be interested in the continuation of the time-independent Schrödinger equation in 1 dimension. This module is subdivided into 2 units. In the first unit, we'll be looking at the simple harmonic oscillator, and in the second unit, we'll be looking at how to raise and lower operators, that is, the raising and lowering operators for the harmonic oscillator. Of course, we'll take our tutor marked assessment to round up module 4, and we'll discuss concepts and problem solving skills. At the end of this course, you should be able to achieve the course objective And the aim of this course is for you to learn the mechanics of the atomic and subatomic particles. And the following are the objectives. Number one, to understand the mathematical needs to understand quantum mechanics. Number two, to look at the inadequacies of classical mechanics and how to get around the related difficulties. Of course, we would also teach you how to derive the equation of quantum mechanical motion. And amongst the objective is for you to statistically interpret the wave function associated with a particle. At the end of this course, you should be able to find possible states in which quantum mechanical particles can be found. You should be able to get the probability of a quantum mechanical property in any particular state, and you should be able to understand the quantum mechanical harmonic oscillator. This facilitation will lead to assessments, and these assessments include the total marked assessments, which covers about 30% of the mark assigned to this course. You would be given several total marked assignments, but you must answer at least 3 out of the 4 total marked assignments that you'll be given at the end of this course for you to be able to sit for the examination at the end of the course. This examination constitutes 70% of the entire mark assigned to this course. And of course, the time for you to sit for the examination will be communicated to you in due time. This facilitation includes a weekly lesson video, just like we are doing, where we highlight concepts and the tasking parts of our course material. Then at the end of the week, we'll have a 1-hour live session where we clarify concepts, we answer questions, and we solve practical problems. In this 1-hour session, we'll have the time to interact with ourselves. And when we interact, we will be able to understand or clarify the concepts. We will give quizzes which you would have to go back home, solve problems, learn concepts, and submit at the end of the day. Also, would take advantage of the available discussion forum, where we would have the opportunity to discuss concepts, look at problems that are difficult to solve, and look at practical ways to make this course more interesting. Also, to strengthen our discussion, the students are to create a WhatsApp platform where they will add the facilitator for us to be able to have access to information on the go. We would use, alongside the discussion forum, the mailing options, where email addresses will be sent to students to notify them of assignments, of discussions, of weekly lesson classes, and of our weekly live session. So thank you very much for being here. Quantum mechanics is a very important aspect of physics that explains the behavior of atomic and subatomic particles. It is a critical area in physics and an area where students fear most. So we'll try as much as possible to demystify the course and pass the message as easy as possible. Thank you very much for joining me on this facilitation course. I also want to clarify that this is not a class. It is to help you understand the course material better. So see you in our next session where we discuss the first module or the first few concepts together. Do have a wonderful day. Thank you.